European Data Relay Satellite System EDRS, a strategic space asset for Europe. Space services have become an indispensable asset for Europe and our society. They help us observe our Earth and climate from space, provide global positioning data for tracking and navigation, and enable us to communicate and send information globally of any kind in real time. Space telecommunication infrastructure is the backbone for these space services. Despite the present telecommunication capabilities, there are still a number of limitations that delay the delivery of time-critical data to users. Primarily, delays are due to the fact that most Earth observation satellites fly around our planet in low Earth orbits only several hundred kilometers above the ground. A satellite appears on the horizon about once every 100 minutes to pass over ground station antennas and send the data it acquired while traveling around the globe. This process only allows about 10 minutes of communication between the satellite and the ground at each contact. Most of the time of its 100-minute travel, the satellite cannot communicate its valuable data to the ground, but needs to store it for later downlink. Secondly, Europe relies on the availability of non-European ground station antennas to receive data from Earth observation satellites. This poses a potential threat to the strategic independence of Europe. Therefore, Europe will require a space telecommunication infrastructure that is independent and provides quasi-continuous data transmission opportunities from space to ground to users. Such improvements may be achieved through the European Data Relay Satellite System, which is a satellite communication system that allows non-geostationary satellites, spacecrafts, other vehicles, and fixed Earth stations to communicate with each other by means of satellites placed in the geostationary orbit. First of all, the visibility period for low Earth orbiting satellites is drastically increased to 45 minutes, enabling longer download periods per orbit to download all data required and when required. Secondly, fewer ground stations are required for downlinking the data, and the location of these stations may be selected such that they can be based in Europe and Canada to increase our strategic independence. Finally, the download of data will be almost instant, enabling even rescue teams to access critical information on demand while operating in the affected regions. There are a number of key services that will benefit right from the start from this system's infrastructure. Earth observation applications in support of a multitude of time-critical services, for example, the monitoring of land surface motion risks, forest fires and floods, sea ice zones. Rescue teams that need Earth observation data within disaster-struck areas. Security forces that transmit data to Earth observation satellites, aircraft and unmanned aerial observation vehicles so to reconfigure such systems in real time. Relief forces that operate among their units in the field and require telecommunications support in cut-off areas. To complete a key building block in Europe's independence, the European Data Relay Satellite System will fill the gap of an independent European telecom network that is fast, reliable and seamless. It will make on-demand data available at the right place at the right time and will ultimately save lives.